Welcome back my dear students, dear participants. A very good morning, a good afternoon and good evening to all the participants and students who are watching this lecture. The title of this course is Multi-Criteria Decision Making, and my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, this is the 31st lecture out of the total set of lectures, which is 60, that is the whole course is spread over 12 weeks, and each week we have 5 lectures, each lecture being for half an hour. The broader set of concepts which we are still considering is multi-criteria decision making, multi-objective decision making, multi-attribute decision making, where we have been discussing time and again the difference between multi-objective and multi-attribute concept, and then further consider multi-attribute utility theory, its implications, how they can be utilized. The coverage for the 31st lecture, and if we spill over, it will be in the 32nd lecture also, which we will discuss, would be further discussion about goal programming. Very simply, the concept of Pareto optimality in 2D space for linear programming, and concept of Pareto optimality in 3D space, which solve problems for a quadratic programming. Again, as I said that I assume and all of you have a good background in mathematics, statistics and operation research. So, the ideas of how to program quadratic programming, linear programming, 0-1 programming, then integer programming are you are all aware of that. So, the concept of very simply of trying to use those algorithms in the purview or in the concept of multi-objective programming is being discussed. And when I say multi-objective, I only am sticking to the bi-objective one, because trying to convey the information how the Pareto optimality curves will look like is much easier in the 2-dimensional case, and obviously, it can be extended for the higher dimension also, like 3-dimension, 4-dimension, considering you have more than 3 or more than 3 decision variables, and also the objective functions are also more than 2. So, as we were discussing, this is the slide which we have discussed and based on which we ended the 30th lecture. The idea was you have the maximization concept here, and the minimization also is being discussed. So, that means there are 2 types of functions. Functions can be different, but there are 2 notions of what you want to do with these 2 different functions which are there. When I use the word functions, it means that when you see f I, I can be more than 1. When you check g j, j can be more than 1. In one case, I collect all the functions f i's and I want to maximize them, and another case similarly simultaneously I want to collect all the functions and g and try to minimize them. Now, the question may immediately come up, which I did touch upon in earlier class or earlier lecture, but I will also highlight that these combinations which you see, I will write it accordingly. One case you can maximize. When I am writing the word maximization is basically related to the first set of functions. Consider there are only 2 functions, f 1 I is 1, g 1 j is 1. So, let us make things simple to analyze that, and then we can extend that. So, when I write max, it means basically for the first function when I is equal to 1. When I want to minimize, I am using the green color and I am writing it in the next place, which is in the second column, which is related to j is equal to 2. Then the other concept can be I want to minimize the first function. So, minimize first function means I is equal to 1. and simultaneously maximize the second function. So, I will write it as let me follow the same procedure which we are using. So, it is there is no confusion with what I display and what I talk and what is written on the slides. So, when we are trying to maximize, so is maximization of f 1, I am not writing x, x can be in multi-dimensional case also, but it is a function of x which is the decision variable, and I want to minimize g 1. Similarly, in the second case, I want to minimize the function f 1, I want to maximize g 1. The other case can be I want to maximize f 1, I want to maximize j 1. The last combination is I want to minimize f 1, I want to minimize g 1. So, these 4 combinations, and if you remember that in the space where there is object function 1 and object function 2, so which you are drawn. So, I will mark objective function O 1, O 1 can be considered as f 1. So, mark it as f 1 and it is on the x axis. It is basically O 2 which is f 2 on the y axis, and if you remember we had 4 different combinations. Coloring scheme I will write down. So, they were like this. The coloring scheme what I am writing down, and I will highlight it accordingly, which is written there in max f 1, mean g 1, mean f 1, max g 1, max f 1, max g 1, mean f 1, mean g 1. So, this was one, the other one is, I am using different colors. So, in order to avoid confusion. So, it should be run properly. So, this is one, and the final one I use the blue color. So, the light blue color, that was a little bit dark blue. So, I will mark it as A. So, the curve as A is B, C. So, when I am trying to consider these 4 combinations A, B, C, D. So, let us see what is the overall idea one by one. I will not erase this graph which I had drawn A, B, C, D, and I will not erase the equations also. So, consider the first one, A part. So, in the A part, when it is there, technically the issue would be that we would try to, and this is objective function 2 which is f 2, this is f 1, and technically for f 2 what we actually would be doing is that we would try to reach the corner point here. So, corner point on the left top corner. What does it mean? It means that I am trying to increase f 2, go up, and decrease f 1, go left. So, if I am considering F1 and F2, so F1 is being minimized. So, minimization color I have been using is basically green. So, I will move in this direction, and the maximization color I have been using is red, which is in this direction. So, maximization has been there for F2, minimization there is for F1, maximization for F2 means basically G. So, also let me remove that confusion also. I used O1 O2 because it was based on the diagrams which we had done. So, I will write so when I am using this. So, this is minimization of F1 and maximization of G1. Minimization of F1 and maximization of G1, basically this diagram would correspond to this point. I am using the same color here as I am using here. So, I am trying to minimize F1, go to the left, maximize G1, go top. So, this is the 2 dimension case. So, obviously, there is 3 dimension means first function f, second function g, and third function h. Now, do not confuse the functional form of the objective function h based on what is written on the constraints. Constraints I have already discussed. Here it was basically written as 2 objectives with I and j can be more than 1 also. So, h what I just mentioned is basically if there the objective function was denoted by h. So, it is in the 3 dimension case. When I use the B one, B means B which is drawn here. So, this is like this. You are moving the bottom left corner going down, which means F1 is being minimized, G1 is being minimized. So, if I consider both of them, this is this part. So, both are being minimized. Now, when I come to C, again I have deleted it, but h can also be obtained or added as a third objective function, and the diagrams would be considered accordingly. So, but only you have to remember that h can also be maximized and minimized. So, for 2 functions f and g, you had 4 combinations: max min, min max, max max, min min. Then when you bring h, obviously h having 2 combinations, it means that now I will have basically 6 combinations. So, one extreme being all the maximization happening for f, g, h, and the other extreme being all minimization being happening for f, g, h. And so, there are technically accordingly 2 for these, 2 for these, and 2 for these. So, it will be 2 into 2, 4, 4 to 2 to the 4 to the 8, sorry not 6, 8, 8 combinations would be resulting from this. Now, when I come to C, which is this, so I am going to the bottom right condition. So, here G1 is being decreased and F1 is being increased. So, if I consider this, F1 being increased and G1 being decreased, so it will be this combination. And Obviously, h can be also considered as a third function. So, if we remove this, I will remove this color also. So, to in order to mark. So, I just wrote max min for the color combination. When I finally come to the D curve, which is here, I increase both of them, which means increase of f1, increase of f2. So, this would become the third part. So, correspondingly, I will mark, which I have already done, but just for A is for this, B part is for this, C part is for this, and D part is for this. So, using this we analyze. Now, considering that we have already discussed, I will erase this and come to the constraints. Constraints I have already discussed, but I will still highlight them. So, the constraints are, so there are, one is greater than type, as you see, the one is equal to sign, and the third one is less than sign. I am using different colors, and the function is h1, h2, h3, and the subscripts k1, k2, k3 means the total number of such constraints are capital K in number, where capital K is equal to small k1 or capital K1, which is for greater than type, plus means union here, K2 being for the equality type, again plus means union, and finally K3 being for the less than type, and X is in the real line of n dimension. Now, what I have explained is written here. So, it will be easy for us to follow, where we want to maximize f1 I is equal to 1 to capital I, while on the other hand we want to minimize g j is equal to 1 to capital J. So, here for simplicity I considered, as I mentioned, I and j as 1, subject to capital K number of constraint, which I just mentioned few seconds back, and they are, again I am repeating, greater than, equal to, less than, and on the right hand side greater than, equal to, less than have been given by the constants. They are deterministic, they are not stochastic, that means constants. It is b suffix k1, for equality sign is b suffix k2, and the last one, when it is less than sign, it is b suffix k3. Here, so here the suffix k1, k2, k3, which are written in the start bullet point, which I am putting a tick mark. So, small k1 goes to 1 to capital K1, small k2 goes from 1 to capital K2, small k3 goes from 1 to capital K3, and here what I wrote the plus is basically they add up to the total number of constraints. And obviously, we consider the intersection of the greater than, equal to, less than is a null set, because they are distinct, and we can, for simplicity, we can differentiate them as constraints of the greater than type, less than type, equal to type. Here x are the structural decision variables, fi and here gj are the set of objective functions, and these constraints are basically the goals. You cannot exceed them, cannot violate them. So, h1, h2, h3, where the number of such constraints for h1 is capital K1 in number, for h2 is capital K2 in number, for h3 is capital K3 in number. bk1, bk2, bk3 are the target values or aspiration levels associated with the respective goals. Collectively, these constraints greater than, plus, equal to, and plus the less than type are called the constraints, total constraints. So, we will consider a problem and expand it accordingly. So, this is a linear programming problem. Suppose one rich farmer in India wishes to grow the following 4 crops which are accordingly rice, wheat, bajra, maize. There are 4 crops. The selling price per kg of this rice, wheat, bajra and maize are respectively 28, 25, 30 and 24 rupees per kg. The cost price per acre for these 4 crops, which are crops are again I am repeating rice, wheat, bajra and maize. The cost price, like you have to use pump set to draw water, you have to pay the person who is tilling the land, use a tractor or a bullock whatever way you are trying to till the land, you have to use seeds, maybe you have to use organic ways of trying to do the farming, or somebody uses fertilizers, whatever it is. The corresponding cost, there would be many costs. The cost per acre for these 4 crops are respectively 33,200 for rice, 30,500 for wheat, 35,750 for bajra and maize is 27,000 respectively. Corresponding the average output per acre. So, there are different outputs, different cost also, different selling points also throughout India, but I am taking a average, very average value. Output per acreage are for these 4 crops rice, wheat, bajra, maize are 1250 kgs, 1150 kgs for the second one, 1200 kgs for the third one and 1100 kgs for the fourth one. The total irrigated land available with the farmer is about 1000 acres, and for each crop at least 100 acres and at most 400 acres of the total irrigated land should have to be used, which means for rice or wheat or bajra or maize you have to use 100 acres and cannot exceed 400 acres per the crops you have. Furthermore, due to water usage restriction, total acreage of rice cannot exceed that, because rice needs a huge amount of water. Rice cannot exceed that of the combined acreage of wheat and bajra taken together. And also, as wheat, consider the person is irrigating in the part of India where wheat is the staple diet. So, considering wheat is a staple diet, hence its production should be more than 50% of the combined production of rice, bajra and maize, because the person has to supply to the market. Finally, for the movement of the tractor, vehicles and other things, you have, say for example, the person wants to lay down a fencing, there are different type of animals like which come and destroy the irrigated land, eat up these crops. So, the person has to put fence and has to use the pathway to take the tractors or the bullocks, whatever. Consider that part of the land is not utilized for irrigation. So, here it mentions finally for movement of tractor and the vehicle etc. to be used after crop harvest, 2% of the total irrigated land cannot be utilized. So, let us see the problem accordingly. As evident, the decision variables for these problems are related to the acreage to be given for rice, wheat, bajra and maize, which we consider as decision variables x1, x2, x3, x4. Now, there are revenue cost based on selling and there are cost also for irrigation, for tilling the land and for production. So, if I consider the corresponding revenues, so if I consider the 2 corresponding revenues, it is the output per acreage for these 4 crops which I will mark are 1250, 1150, 1200, 1100 for wheat, bajra, rice, wheat, bajra, maize, and if x1, x2, x3, x4 are acreage for these 4 crops respectively, and if I consider the selling price given as 25, 30, 28, 25, 30 and 24. So, obviously, you have to multiply the corresponding factors to find out the total revenues, which we are doing, which is 28 for the first one, which is here, 25 for the second. I am again repeating it, please do not mind, 30 and 24. So, when I multiply is 28 into 1250 into x 1, which is the total acreage for the first crop rice, 25 into 1550 into x 2 for the second, 30 into 1200 for the third into x 3, and 24 into 1100 into x 4 for the fourth. So, this f x gives you the total revenues. Now, when I come to the cost function. So, if you note down, the revenues are marked here in blue, cost are also blue. So, I marked the revenues. So, now as per the concept given here, the total cost price for the acreage for these 4 crops are given as 33,200, 30,500, 35,750, 25,700 and per acreage. So, acreage for these crops are x 1, x 2, x 3, x 4. So, when I find out, so this is 35,000 x 1 plus 28,750 into x 2 plus 36,000 into x 3 plus 26,400 into x 4. So, this is the cost function, and so this is if I consider G. So, now if I consider so this was sorry this was I just missed it. So, my mistake. So, this was basically the cost function given accordingly, my apologies. So, when I multiply them for the revenues, they were coming as 35,000 x 1 plus 28,750 plus into x 2 plus 36,000 into x 3 plus 26,400 for x 4, and the corresponding equation for the cost are, which I have not read, I will just mention it, 33,200 x 1 plus 30,500 x 2 plus 35,750 x 3 and 27,000 x 4. So, there would be analysis for them problem, which we will do in the subsequent class. I will just show this and then continue the discussion for this lecture. Thank you very much and have a nice day.